All right, everybody, welcome back. We are on lesson number 21, and it is finally time for us to be using some graph paper. So, lesson 21. Graphing linear functions. Now, we'll go ahead and say if you don't have graph paper, that is fine. It will probably take you just a little bit longer to catch up with us in this video, so make sure you're pausing it as needed. Also, I'm just going to post a quick link to some printable graph paper just in case you would rather use that. Here's that link. Okay, so first, this applies to anybody if you're using paper, just regular paper or graph paper, is how do we draw one of these coordinate planes? So first, we're going to draw a vertical and a horizontal axis. And do the best you can to make it stick out in all directions about the same. Okay. Now, if I had had a ruler, would have been nice, crisper lines, but it's okay. It'll be fine. So this axis is the x-axis, and this axis is the y-axis. And so as we are graphing these guys, we're going to want to keep on drawing these. Now, we are supposed to label your x and y axis, so like little tick marks, like so. I will go ahead and say I'm picking examples that will make this quite a bit easier to do without having to worry about labeling, because honestly I think writing 1, 2, 3, 4, 5, 6 and 1, 2, 3, 4, 5 and -1, -2, -3, -4, -5, -6 and -1, -2, -3, -4, -5. 1, that is time consuming, and 2, it takes up a lot of space on our graph, okay? So I am picking examples that we really don't need to worry too much about labeling as long as we are aware of what each little jump means. Now, if you are doing this on paper, you've got the extra little bit of difficulty here because you don't have this little grid that shows you the spacers between each of these tick marks. Okay, so what you have to do is very, very carefully, to the best of your ability, keep each of these tick marks spaced about the same, going both directions. Okay, so what I've done here is I've just free-handedly drawn a coordinate plane on a sheet of lined paper, and so as you're drawing these, just notice that like the little inconsistencies between the gaps between the tick marks on the y-axis, we'll be fine using this. It's just that our graph will be a little bit wonky, and if I try to use a ruler to draw a straight line, it is going to kind of be not so perfect, but it'll be fine. Okay, but back to my graph paper. Let's say I want to graph y equals 2x minus 4. 2x minus 4. There's a couple of steps here. One is to identify the y-intercept. Well, the y-intercept is just this number hanging out back here. So b equals -4. Once we've got b, -4, identified, just find -4 on the y-axis and plot it. So make sure you're plotting that first number on the y-axis. Now, if you remember thinking back to what the y-intercept meant, it always meant a starting value. Like if this had been describing someone's, I don't know, savings over time, we would see that 2x means they're saving $2 per week, but the -4 means they already owed $4, so there were $4 in the hole. But that's always the starting or initial value, and we always start right there on the graph. Next, step 2. Use the slope to find more points. So the slope is 2. So how do we use that to find more points? Let me zoom this in just a skosh. Maybe that'll help. Okay, so with a slope of 2, that's a positive 2. This is kind of telling us some directions of some steps we need to take. We're going to go up 2 steps and right 1 step. So starting at the y-intercept, count up 2 and right 1. Then do it again. Go up 2 and right 1. And do it again. Up 2, right 1. Up 2, right 1. Up 2, right 1. At that point, I'm pretty much falling off my graph. The only other point that I could describe is we could go back and down the opposite directions here. So down 2 and left 1. And that'll help us pick up one more point right here. So the game is always go up 2 over 1, up 2 over 1, up 2 over 1. But we can sometimes pick up some additional points that'll help us flesh out our graph. And then, because these are linear functions, use a ruler or some sort of straight edge to connect the dots. If you don't have a ruler, or if you're using just regular paper, you might try to connect the dots and see that it doesn't perfectly fit. It's okay. As long as you've got the basic gist of this graph, we should be good. Okay, let's try another one. So I'm going to go ahead and draw a graph. So again, I tried to make sure that my X and Y axis went about the same distance out in both directions. And then I'm not going to worry too much about labeling these. Tick marks, they're just going up, down, left, and right by 1 each. Now it would be important to label the tick marks if we had like wild, crazy numbers that were going off in a bunch of different directions, but here we don't have that, so it doesn't really matter. So, how about we graph negative 3x plus 5. So, the y-intercept here is the positive 5. So I'll find 5 on the y-axis. That's 1, 2, 3, 4, 5. Make sure you're putting that on the y-axis. It's a really easy, common mistake for people to put that over here. That's not the y-axis, that's the x-axis. So start with the y-intercept. It's 5. Then, second step is use the slope, which is negative 3. Make sure you keep that negative in front of it. Now, because the slope is negative, we're going to go down 3 for every 1 step right. That slope of negative 3 says go down 3 for every 1 step right. So starting at the y-axis, or excuse me, the y-intercept at 5, go down 1, 2, 3, and right 1. And down 1, 2, 3, and right 1. And down 1, 2, 3, and right 1. And if I try to do it again, I'll fall off the graph, so I'll just stop there. Then use my straight edge, my ruler, whatever kind of nice straight little side I've seen people use the side of their phone before, or the side of a book. Just whatever you've got that'll help you draw a straight line, and if you don't have it, just do the best you can. Okay, I'm going to pop up another one for you. So I would like for you to try this one. Go ahead and sketch a coordinate plane and see if you can graph y equals x plus 2. Now before I go ahead and pause the video, I didn't forget to put a number in front of x. There's just not a number there. So think to the back of your head, what do we remember about if there's no coefficient on x? What is that understood coefficient? Okay, take a moment and try to graph this one. Okay, so first off, the y-intercept is 2. So on this graph that I've not labeled or put any tick marks on, because I'm on my graph paper, I can go ahead and just call this 2. So the slope, my step 2, the slope is 1, which is going to tell me to go up 1 step for every 1 step to the right. Up 1 and right 1. So go up 1 and right 1, and do it again, and again, and again. Now, we can also pick up a lot more points if we go down and to the left at the same angle. So starting at the y-intercept, go up 1 over 1, up 1 over 1, and go down 1 and back 1, down 1 and back 1, down 1 and back 1. Oops. And I just dropped my protractor there. And then I will connect those dots. Oh, it's getting in the way of the little rings of my notebook are getting in the way. And there we have it. Okay, I'm gonna pop up another one. Okay, for the next one, go ahead and draw you a nice pretty coordinate plane, and then try to graph y equals 2x. Now, again, I didn't forget to write something there. There's something that's intentionally missing. We've got the 2x, so we know our slope is 2, but the y-intercept, there's nothing there. So be thinking about what number represents no number. Okay, take a moment and try this one. Okay, so first off, that missing y-intercept. That y-intercept is 0. If there's no number back here, it's technically plus 0 or minus 0, same difference. But that means our y-intercept is 0, also known as the origin. Well, then we can use our slope of 2 to go up 2 steps and right 1 step. Make sure you're going up 2, but just 1 step right. So up 2, right 1, up 2, right 1, up 2, right 1, down 2, left 1, down 2, left 1, down 2, left 1. And then I will connect the dots. Okay, let's try one more to my document camera. This poor little guy right here, he's very sensitive. If I accidentally hit it with my hand, which I do quite frequently, it disconnects from my computer. There we go, we're back. I hope you didn't mind seeing me in double time there for a second. So let me go ahead and pause this and pop up a new equation to graph. Okay, for our next one, take a moment and try to graph y equals negative x plus 6. Okay, so first step is the y-intercept, which is just 6. So count up 1, 2, 3, 4, 5, 6. And then second step is to use that slope of, well, that negative without a number there is just -1, which tells us to go down 1 and right 1. So down 1, right 1, down 1, right 1, down 1, right 1, and so on. And at that point, pretty much hitting the edge of where my graph is. And so there is my line. Okay, so at this point, I think we're good to go ahead and call this video over. I'm going to pop up a few more graph questions right here. And thank you so much for watching. Let me know if you have any questions. Hope y'all have a wonderful day. Bye.